So welcome everyone to another collaboration, New Way Growth and ConeX, and we are discussing additive manufacturing, and we have Seamus here. So I will hand over to Sam to do more of an intro around this session, and we'll go from there. So please do ask questions in the comments as you're watching as well. So
Brilliant.
Sam.
Thank you very much. So obviously this is our first event of November. In the new structure that we're working on with ConeX. So we're going to start with an introduction session on LinkedIn, as you see here, and then we're going to move over to a mastermind ConeX members session next week, and then follow that up at the end of the month with an in-person event. So I'll talk more about those sessions later on in this discussion today. But our theme, so all of those sessions are going to follow a certain theme, and we'll run that throughout 2024, different theme every month. So if anyone's got any ideas on topics and themes, then please let me know. So this month, as you can see, we've got Seamus from Mark3D with us, which kind of makes it self-explanatory what the topic is going to be around. So the focus is going to be on adoption of additive manufacturing, opportunities that this presents, the challenges, and the new technology that's available in the sector. So we've got a few questions for Seamus and Adam, because obviously Adam's in the additive world himself as well. So we've got a few questions to run through this morning. As I say, we'll keep this live for 20 minutes, 25 minutes, have a bit of an introduction, learn about what these guys do, and then bring this over to a bit more of an in-depth mastermind session next week. So to start with, I'll let you introduce yourself, Seamus, and what you do and who Mark3D
are. Yeah, thanks. Morning, everyone. My name is Seamus. I work for Mark3D. Mark3D are a UK partner of Markforged. So we're what's known as a solus reseller. We've solely focused on their technology. Markforged are a US-based 3D printing company, and they're on a mission to bring industrial 3D printing to the point of need. So yeah, we work with businesses throughout the UK to evaluate, adopt, and ultimately get the best out of 3D printing, but predominantly Markforged machines.
Makes sense. What's your, going a little bit off topic already, what's your kind of background and links into the additive world? Why have you gone down into the kind of Mark3D world, Markforged?
Personally, myself?
Yep.
Yeah, so well, my background was actually CAD. So after doing an engineering degree, I was in the SolidWorks channel for a while. And I think for me, additive manufacturing, is sort of on that curve of where 3D CAD was, back in, say, the 90s. So for me, being early on in my career, it seemed like a perfect technology to get behind. It is, of course, really interesting, really exciting as well, and the depth of it, and also more of a manufacturing focus, whereas CAD is more of a design focus. So I've been with Mark3D for 3 years now, and it's just been incredible to see, what customers are doing with 3D printing, the technology advancements that are happening, both within Markforged and wider in the industry.
That makes sense. So as a reseller, you go out to customer sites, kind of learn a little bit about the customers, learn about what they're up to, what their potential challenges are, and then essentially present solutions and then provide the kit. Is that right? Or is it then an ongoing service beyond that?
No, that's it. Yeah. So we do the full customer journey from, right from understand, early stages, understanding what problems they're having or getting into additive manufacturing, whatever it might be, right from when they first sort of inquire into getting into this world, right through to supporting customers that have been with us for years, understanding how they can do new applications that they haven't focused on, improve their design for additive manufacturing, which is a huge part of it. It's very easy to pick up a printer and just print things that you've already been doing. But, the real trick for me with 3D printing is to actually, go beyond that, and think I've got this new piece of technology, that can do very complex geometry, and actually change your designs, rethink the way you design things, and solve problems with it.
Yeah, that makes sense. just to bring Adam into it, what's your links to the 3D printing and additive world?
I'm trying to think how we come about into it. We'd predominantly been with Doncasters, execs in Doncasters. We were looking at 3D printing quite a way back, particularly on the metal side. When we set up the businesses, it sort of like was a offshoot of what we were doing from the manufacturing consultancy side. So it ended up with, originally for me, I had a machine that was sat behind me here in this room, and I was messing about with it. And I think, like Seamus said, the thing for me is yes, you can get a 3D printer and you can print anything, the normal bloody Marvel Groot and bloody Iron Man and things like that. But the actual value for me is the thinking process within design, and how, like Seamus says, is you can change your way of thinking within design, and the 3D printer will be able to adapt to what you're looking at. So it advances our design skill a whole host more, in my opinion. And to be fair, I don't think from a design point of view we've potentially got the most out of 3D printing yet, because we're principled in our approach within our design approach. You know, we'll take, I think we had this discussion with Ram not so long back, is that, you know, from a design point of view, Autodesk and the introduction of AI into it and the design side, you end up with like an aircraft, I think it was a arm that would normally have been made up, our normal design route would have been about 3 or 4 parts that were all assembled together to create the structure. Whereas in 3D printing and with AI, it actually created this tree. And it, you know, it was just one piece. There was nothing. It was just 3D printed in one piece. And lightweighting, the stress is taken into account and everything like that. And when you look at it, and you look at it from a human brain into what it was actually there, the human brain probably wouldn't have actually designed something like that. So that's where I see the advancements on. You know, and that's where it was just through intrigue and seeing an application that we went into it. Ours then progressed on to other stuff, you know, from a consumable into an e-commerce side. But the I don't think we've really seen the advancement of it yet. I think this, I mean, I don't know what Seamus thinks here. I think there is some movement that we need to have within the materials aspect, particularly with plastics, from a sustainability point of view. But yeah, that was my 2 pennies worth. It took about 5 minutes.
I think the generative design stuff is really interesting. I've worked quite a lot of that on the Fusion software from Autodesk. And ultimately, that whole aspect of design, in that designing real world pieces or real world elements that effectively can't be manufactured any other way than 3D printing. And none of that would have existed without the technology of 3D printing. If you don't have the technology to produce these things, then what's the point in designing them this way? But you're right in terms of no human would be able to sit down and design some of these things that these kind of AI and technology softwares are now putting out. No one would ever think like some of this software does and how these things are produced. If anyone just goes literally a quick Google search and searches generative design, you'll see what we're talking about, because it's fairly impressive stuff in terms of some of the things that are going to come out. And it is, as Adam said, it's all about lightweighting and improving the structures and actually giving some of these pieces even more strength than they had previously as well. A lot of these components were previously fabricated out about 6 or 7 pieces. If you can now manufacture them using a different technology, a different design, then it's improving the process in total. So we do have a few questions coming in, which we'll get round to in a second. We're going to loop this back round to Mark3D and Markforged, because obviously that's the whole point in this session. So let's go with the most exciting and upcoming developments within Mark3D and Markforged that you're seeing at the moment, Seamus?
Sure. Well, I mean, actually, for me, I think a lot of it's around the software. Adam sort of mentioned on materials there, and he's right. You know, materials can go a long way. Not necessarily software, but sort of the process through 3D printing. You know, we have just had Formnext this week. You know, I think I'd be shocked if I didn't say that we launched the new FX10 printer there as well. You know, that is a huge excitement. That's, you know, now the 5th generation of printer coming from Markforged. So on the hardware side, you know, that's just getting better and better as they iterate, you know, as they learn more about printing systems as well. You know, so that machine's going to have a lot more capabilities, you know, a lot more sensors and understanding of the way that the printer's working, improvements in accuracy and reliability. But actually, I found over the last year, Markforged specifically have done a lot around the software and the sort of process and policy side, if you like, of printing. You know, if you think about aerospace and automotive, you know, we've got a lot of customers that say, you know, that's great, we can print these parts, they're super strong, they're super accurate, but what's not necessarily always behind 3D printing is the processes that are in place. You know, the certificate of conformity for materials, simulate, you know, virtual simulation, inspection of parts, and that doesn't necessarily always mean dimensional inspection. Sometimes it means actually internal inspection of the way that printed parts are made, because specifically on the Markforged side, we have continuous carbon fiber inside parts. It's the process of, I've designed my component with this carbon fiber layup. I now want to print that 20 times. How do I verify that the carbon fiber is exactly where I've placed it? Yeah. You know, really the only way probably without Markforged software is some sort of X-ray, you know. Now we have a inspection software on the printer with a laser in the printer head, scans the print every layer, gives you your point cloud geometry straight off of the printer. You know, that allows you to more quickly get your dimensional inspection and also do that internal geometry that actually, you know, wouldn't be able to be scanned after the print's finished. You know, so that allows a lot of businesses to now, you know, put use parts, end use parts in applications where you need that level of you know, that level of certification that's in there.
Okay, so go on, Adam.
I was just going to I was just going to say, we've seen the introduction of AI in the design side. How are you seeing the advancement of AI within the machine side?
Well, this inspection software is actually a side of that. So Markforged launched a software that they called Blacksmith, which was essentially an AI software that takes all of this information from the printers and this scanning, and then can use that information for lots of different things. You know, some of them are probably undefined yet, but you know what that allowed them to do was create this inspection software from that. And I think, you know, in the future, obviously don't know exactly what's going to happen with it, but I think we will see more and more instances of the software that's driving the printers actually have more real-time understanding of what's going on. You know, a lot of the printers now have sensors on them that can track whether the materials run out, whether the materials running correctly, you know. But let's say, for instance, you're printing something and it's slightly out of tolerance, you know, you're 25% through the print and something's gone wrong, something's off. This software might actually be able to identify that real time, you know, because of the telemetry, the point cloud data, everything that it's gathering. And I think that sort of quality, I think it could make the prints more accurate, but sometimes it's not always about additional accuracy. It's more about additional like quality assurance and, you know, like real-time quality control, you know, and pausing the print.
I guess there'll be an element of kind of auto correcting itself as well.
Yeah, that's the way I see it, is the integration of the AI into actually knowing that something is potentially going out of tolerance, but of being able to adjust it within the program live in real time to bring it back in.
That's right.
So you enhance the quality.
And above that as well, you know, telling the user almost exactly what the problem is. You know, like I've understood that this is exactly what you need to change on the printer. Hardware side, you know, that's slightly off. Maybe it's belt tension, maybe it's some bushings that need changing, and maybe it's a consumable tube that, you know, it almost can understand and troubleshoot for you, which just again makes the 3D printers what they are, which is such an easy tool to use. You know, again, I said I'm from a CAD background. You know, I couldn't run a machine tool. You know, I'd probably maybe find the on button if I was lucky. You know, but I can run a 3D printer with a couple of hours worth of training. You know, it's just unbelievable how these 3D printers can run themselves. All of the understanding of it is in the software. All that intelligence of how to 3D print is in the software. Which, you know, really is a benefit, because it means engineers can get on with, you know, what they need to do, designing parts.
Yeah, which kind of actually leads on to my second question, which is how can the software, how can the printers, how can the, you know, some of the Markforged technology actually be used to solve some of these real world problems? And I guess do you have any specific case studies that you've got off the top of your head that give this a kind of example of where some of this software, this new technology is actually being used on a daily basis? Because it's all well and good saying that it can do all these amazing things and there's all this technology out there, but is it actually being used, and where's it actually being used?
Yeah, I mean, I've got quite a nice, because I could go on all day about customers and case studies and what they're doing and things, but I guess I've got a nice anecdote which is a bit less sort of you know, someone bringing in a 3D printer to do a certain thing. You know, we've got lots of customers who are running, you know, multiple printers to do end use parts, to actually, you know, put in products to sell and things. But I guess there's a nice anecdote of a customer that bought a printer for, you know, reducing their tooling cost, you know, getting things quicker, and then the printer becoming a tool that they can use day to day as a business. And I guess that's sort of where you say it, you know, it's solving a real world problem real time, rather than necessarily, you know, being a production tool for you, which it can be as well. But we had this customer that sort of bought it for, they were going to use the printer for jigs, fixtures, you know, CMM jigs, holding parts, and they had a machine. They had a machine in their shop that was, or their production line, that must have been 35 years old, and this pulley just completely wore. They couldn't buy it from the original vendor, so they would have had to get it remachined, you know, so you're talking, you know, a few weeks probably to get that done, whereas they printed a nylon one overnight for like £8. You know, yes, it's not going to last as long, but it gets your production line back up and running while you wait to get the actual metal one produced, you know. And even if it wears after a week, you just, you know, pay another £8 to get it redone, and off you go again, you know. So that's always a nice anecdote I go back to, because we find this all the time. You know, the 3D printer goes into a customer for a certain reason, you know, and they get great ROI on reducing their tooling costs, or you know, making end use parts quicker, whatever it might be. But it always becomes that thing that when, you know, the group of engineers are sitting around the table saying, what we're going to do about this, it's always something they can look at in the corner and go, you know, we can probably makeshift something with a 3D printer to get us through, or actually do something long term with it as well.
Yeah, I've talked about this before on one of these sessions, actually, around, I can't remember the company off the top of my head, but a company that basically built a suite of 3D printers. They had no purpose for them. They they were not in their day-to-day work. They just put them in the office and just allowed staff to play around and use them as and when they wanted. And the amount of things that came up which actually then helped their production moving forward, just because they just gave the staff the option to learn something new, have a little bit of a play around in their lunch breaks, whatever it may be, send some files to a printer, see what you can actually make. That massively increased productivity, and it's just something interesting, different for staff to look at as well. So yeah, I completely agree with that one.
It's fascinating because I mean I've got 4 here, so I've got a small like little print farm in the garage that I do all the motorbike stuff. That my hobby is motorbikes and things like that. But as I sit here now, and I was just totting up, I must have probably 15 different items that have printed out in front of me here that have increased the productivity of my day. So the laptop that's in front of me now is on the stand that has been 3D printed and designed for the right height that I need. The camera that you see is actually mounted, that is enabled and is designed with lights, the camera and everything, and is adjustable for different scenarios. The monitors either side, there's just loads, and it's that application. But the real world side of it is that on some of this in answering that question, it's thinking around some of the third world countries and the possibility of actually taking a small little printing machine portably with you that could potentially run off of solar power and be able to create and farm parts, things like that, as Seamus says, you get up and running until that other part comes. So the opportunity, but it's about thinking differently around it, not in that normal sort of like way we're trained, the engineering side. We've got to think a bit more creatively in it, that creative thinking. So he's typing away now. I can see him. He's typing away on something.
There you go. I'm putting some links in the chat for people to join our next sessions. So following these sessions, as I've put the links in the chat there, next week we've got a ConeX mastermind session. So we're going to go into a little bit more detail and more depth and answer some more questions. Speak to Seamus. I don't know if you're bringing any of your team along potentially to that one next week. So we can ask a few more kind of in-depth questions around people's within the ConeX community, their real life issues within 3D printing, or if they're looking to start some 3D printing, just have a bit of a problem solving session together. And then at the end of November, we're actually coming up to your new facility in the Midlands, Stourbridgey area, somewhere up there, to have a look around and see what you've got going on, and hopefully see some of these printers in action as well. So before we bring this to an end, last little bit of advice that you would give people that are new to the sector, new to 3D printing?
I mean, I think we've touched on mine already probably earlier, which is again to just rethink your design. It's very easy to bring a 3D printer in, and there's huge ROIs very quick to just reduce costs, make things quicker, and that's great, but to get you going. But to really get the best out of a printer, it is bring it in and actually change your whole sort of outlook from the start of how you design parts to be 3D printed. And a bit like what Adam mentioned there, actually get your engineers using it as well. Obviously don't go crazy, but allow them to just go and have a bit of freedom and a bit of time, because it is a tool that they can just innovate with so quickly, and we see this in so many of our customers. You just give some sort of structured sort of free rein to innovate now and again, and it's amazing what they get out of it. Engineers can see the result of their design so quickly.
Yeah, that's the thing, isn't it, Seamus, for me, is that engineers, we like to touch things. We like to pick up and hold something and see it. So we've designed it, but we'd end up like picking it. And normal routes would take us quite a while. You gain it, machine it. But 3D printing, it's like that. You would let it run overnight and it's done. Or, and you've got something tangible, tactile in your hands that you can look at, that you've designed. And, oh yeah, we can tweak this. You can talk around it. It just brings a different, more immersive dimension to it, I think, into the design side. But
Completely
you know,
agree.
which is right,
Looping
yeah.
very quickly back to Luke's question. If you are going into the hobbyist side of 3D printing and you're just looking to get a bit more of a kind of budget printer just to get started, so you can build a few parts, so you can make a few camera brackets or whatever it may be for yourself, is the software side of it as important at that point, or is it more get started? I know there's plenty of free kind of slicers and software that's out there that can be used, or can you improve a budget 3D printer with better software, or are there still limitations that you can't really improve on?
It's not my area of expertise, the hobby side, but I mean, so the hardware will give you some limitations. You know, ultimately the sort of accuracy and reliability of a printer is going to be down to the structure of the, at least if you're talking like filament-based printing, you know, it's going to be the structure of the motor and the belts, and that sort of drive system. You know, if that's fairly unstable, then, you know, any piece of software isn't going to get the best out. But you can, yeah, but on the flip side of that, if you do have, you know, half decent hardware, you can improve the accuracy and quality of a 3D print in the software 100% by tweaking everything, you know. And that's where I talked earlier about when you're industrial 3D printing, that's the intelligence that's in the software. You know, the intelligence in the Markforged software is to take some geometry, give it some parameters of layer heights and things, and the software says this is the best way to print it, the best tool path for the printer to get accuracy and surface finish. And that's what on the hobby, that's the sort of hobby side of it, you know, is to actually have that fully open source and change everything, you know, about it. But, you know, that can take a lot of hours and a lot of spaghetti prints to get to that point. So yeah, I guess the answer is sort of half and half, you know. Ultimately the hardware will give you some sort of constraints of how accurate and the surface finish you can get, but on the flip side, software and the way that you print a part can make it better on the same printer, if you like.
I think the thing that I would add to that on this one, and then this is like completely off topic side, but the hobbyist side is where I see the potential within the younger generation. So the younger generation that is showing an interest into engineering, they need to have access to 3D printers to be able to experiment and drive their enthusiasm even more into what engineering and manufacturing and design is about. So this is where we do need the schools and, you know, and the parents to invest in a little bit, to, you know, because they're not expensive. You know, you can pick up a secondhand one that just gets them involved and gets them doing stuff. And I see a massive potential in that. You know, in particular with the younger generation. You know, so the hobbyist side plays a big part for me in the younger generation and bringing the next set of talent that we need through. And it'll have that, and the younger generation will have that different thinking because they've been exposed to that sort of like tech early on. So yeah, that's just my part of it.
Brilliant. I'm just making a few notes on some questions and stuff that I want to discuss next week in the mastermind session. There's going to be a few around sustainability and recycled materials and that sort of thing. So Seamus, get your thinking hat on to answer some of those questions from me. So I think we'll bring this one to an end. We're getting close to half an hour. So we'll leave this one as it is. As I say, I'll put the links in for our 2 upcoming sessions. So we've got the mastermind next week and then the in-person event on site in a couple of weeks' time. Nothing else for me to add. Is there anything either of you two want to add?
The only thing I was going to add was, you know, from the ConeX point of view and these mastermind groups. I mean, if there's any part of the ConeX and not understanding around what ConeX gives from a community point of view, you only have to go for these because, as I say, this is an introduction in live on LinkedIn. but within ConeX are the mastermind groups as well. So the problems are coming together as a community and solving those problems around that. So they're in a little bit more detail. And that's just one sort of like benefit of actually being a member within the ConeX thing. So that was the only thing. So I was just going to give ConeX a bit of a shameless plug on that. Thanks, one, Adam. Because it is around that mastermind group and that community and that driving. But you can only get that by being part of the ConeX membership. Exactly, because it is,
And we will make use of some of these member questions that are coming in. So Ian's destructor question, which we're going to talk about next week as well, in terms of cost of acquisitions and bringing some of this into the business and actually doing some real life, almost calculations and case studies for people. But as I said, as Adam said, we're doing that within the ConeX community, hopefully adding value to your business and what you do within the sector. So thank you all for joining and listening, and we will see some of you next week.
Yeah. See you later.
Thanks.
There you go.